What about human capital investment? What are the 3 inputs to human capital investment? Milo, do you remember?
Education. I don't remember.
So think about it. What are the 3 generalizable conditions that let us be more productive as workers? Education is one of them. If I'm in my 60s, weigh in 270, 280, have diabetes, probably I'm developing or have already developed a heart condition, how productive am I versus Nate, who's sitting back there with the guns and the hair and all this kind of youth stuff? Am I as productive? Probably not.
So
And, pardon me?
would health be one then?
Health is one. Yeah, sorry about that. I was trying to lead you down a garden path and didn't tell you the punchline. Yeah, health is one. If I live in Madagascar,
Mobility.
mobility, migration, right? So migration or immigration, education, and health or healthcare are the 3 generalizable inputs to human capital investment. If I invest in my education, I invest in my health or healthcare. If I invest in my immigration or where I am, I can put myself into more productive environments, and therefore I can earn more monies or more benefit utility. But it costs me something, right, to do each of those things. So we have to think about what's the cost versus what's the benefit. And we actually think about what is the present value of the benefit and what is the present value of the costs. And so the present value of the benefits is the sum of the benefits of times t divided by 1 plus some discount rate to the t, and the present value of the cost is the sum of the costs at times t divided by 1 plus a discount rate to the t, such that we have the present value of the benefit minus the present value of the cost is the net present value. And a net present value that is 0 doesn't mean there's 0 benefit over cost. It means the present value of the benefit versus the present value of the cost is equal to 0. Well, the present value, because of this rate, this discount rate, which is probably a percentage rate of some kind, when the net present value is equal to 0, that means that we get as much rate, interest, etc., as we expect. No more, no less. When the net present value is greater than 0, it means we got more of a rate than we expected. When it's less than 0, it means we got less of a rate than we expected. So I think in our review problem, we modeled that the cost of tuition, income before going to school, income while in school, income after school. If income before school is greater than income during school, then the difference between those two is a cost, right? Something you're not going to get, it's a cost. And that has to exist for each of the years you're experiencing this. And as we consider the income you might receive after school, let's say you're earning $45,000 a year now, you believe your education can put you at $80,000 a year. The difference between those, 80 and 45 or 35,000, that's the benefit that we're looking for. Our benefit is the extra income that we get because of the investment in education. And we can think about the costs and the benefits. We can model them out after each year, because we know that each of these is simply the cost or benefit. I'll use the benefit one up here, I prefer it. So the benefit at time 0 divided by 1 plus r to the 0 plus the benefit at time 1 divided by 1 plus r to the 1 plus all the way through the benefit at time, I'll call it infinite, divided by 1 plus r to the infinite, or whatever it is, maybe just n. You wouldn't do it infinite, you would do it to some ending point, because you're assessing these at a finite period of time. So let's call that n instead of infinite.
Are these equations going to be something we're going to want to have memorized for the near future?
Yes. Just like they were useful in your review problem. This is me. Just so you'll know, I introduced myself this way at the beginning of the term. You may have seen it in the videos. My economic training is as a human capital economist. Okay. So yeah. And as you think about it, this time value of money construction that we talked about is critical in business. So be able to think about a generalized construction of an equation and be able to solve it. If we had 5 periods here, and let's say we decided that we have some upfront cost. Let's say I'm migrating from Botswana, and the cost of my migration, and it's upfront, so it's at time 0, is $30,000. And then I have a benefit in year 1 that is, I get an additional income of, say, $20,000 a year over and above what I was earning before. Which actually, as it turns out, is actually $30,000 of extra income minus $10,000 of resettlement cost during that first year as well. So it's a net benefit, right, during that particular period. And the next year, I've got a benefit of 30, and then that is constant all the way through year 10. I can give the structure of the equation that is being revealed here. Oh, let's say, by the way, that I have a discount rate. My discount rate, as somebody that has come from Botswana, is going to be high because I'm afraid, right? I've never been in the United States. I don't know what I'm getting myself into. I know I'm never going to see my mom again. So I better be getting something meaningful out of this. But I also know I get to leave the impoverishment of Botswana, if it's impoverished. I've never been there. I'm never going to see those plains or mountains again. I'm not going to be in those villages. My best friends, my family, so I better get a lot out of this. So I have a discount rate of 18%, way over and above inflation, treasury rates, etc. Yeah.
So just real quick before you continue, you mentioned the upfront cost. If just to think about if there wasn't an upfront cost, would our equations start with a b to the 1 over 1 plus r to the 1?
Well, your equation still would be some benefit at time 0 divided by 1 plus r to the 0, but it would be 0.
Oh, okay.
So it's going to be 0, and you're welcome to leave it out.
Okay.
But it's still there. I just want to make sure you understand it exists.
Yeah, gotcha.
Okay? It's just the benefit is 0 at time 0. Now, maybe there's a cost at time 0, right? Because nothing in this is free. This is an investment. But I would go ahead and write this equation as my present value, or maybe it's my net present value even, which is going to be, what did I say? I've got a negative 30,000 and a 18%, so 1.18 to the 0. What is any number to the power of 0? 1. Whether this is 37 million to the power of 0 or 1 to the power of 0, it's still 1. So that makes sense. So I haven't discounted this expense that happened today. There is no time to discount it. It's at time 0. And then let's say the next year, then I've got this $20,000, 1.18 the first. The next year, it's gone to $30,000, 1.18 to the second, plus 30,000, 1.18 to the 10th. And let's say I want to adjudicate this or assess this and whether it was worth it over a 10-year time span. In me doing the ... deal here, it doesn't mean that there isn't a third, fourth, fifth, etc. period that doesn't have to be calculated. There is. It's just shorthand. So if you're asked for the structure of or something about the equational form, that would be a valuable and accurate answer. But you still, if you were going to solve it, would have to solve this number and this number and this one and every one in between and this one, and then add them up because it's a summation. And that would give you a present value, or in this case, because we're netting out costs against benefits, a net present value.
So the negative 30,000 is because that's the initial cost
Yep,
of moving?
of leaving,
Of
in this
leaving.
case.
Okay, so
Which may not happen only in 1 year.
You
Might
deduct
happen
that.
over a period of years.
okay, but that's deducted from that final number. That's why it's a negative here.
That's why it's a negative. That's
And then
exactly
the
right.
rest is adding back to your additional wage in the new country, and then you're seeing if that $30,000 plus the $10,000 moving cost, so the $40,000 is worth it now.
Right, so in this case, I had $30,000 upfront cost, and I had a cost that hit me in the first year, right? They just netted out in the first year to be a net benefit. I could have just as easily said that it was plus 30,000 divided by 1.18 to the first minus 10,000 divided by 1.18 to the first before I went on to the second period. But those are going to net out to positive 20,000, right? And that's how you think about adjudicating whether or not this investment decision is worthwhile. Questions?
So can I just assume that I don't even have a calculator, my first step is just making sure that it's a negative 30,000? Like if I just start at 1.18 times to the power of 1, and I can solve all the way down, and then I just have to remember to take 30,000 out?
Yes.
Because
Yes,
it's
exactly.
Because it's 30,000.
Exactly.
Okay.
Yeah. So you could have taken all of your benefits, get a present value, and then all of your costs and get a present value. Take the present value of the benefit minus present value of the cost. And that's a credible way of doing it. Or you could have just done all your benefits as positives and then all your costs as negatives. But make sure you start your time frames over. Make sure you have the right time signatures. They're exponents, they're real. Okay. Yep, absolutely. Because fortunately in additive, it doesn't matter what order they come.